Hey everyone, welcome to JS Cafe, and in today's video we are going to discuss about critical rendering path, that is also known as CRP. So without wasting any time, let's get started. So for all the definition and terminologies, I'll be referring to the MDN documentation for CRP. So let's have a look what MDN has to say what is CRP. So critical rendering path is a sequence of steps that the browser goes through to convert the HTML, CSS and the JavaScript into pixels on the screen. Optimizing the critical render path improves the render performance. So what it means that is CRP is basically the step of converting the code of HTML, CSS and JavaScript into the pixels on your monitors, right, on the screen. Basically is what known as CRP, and there are multiple steps that are present inside the CRP process. Okay, so there are 5 steps. That is, first of all is the creation of DOM. Another is creation of CSS OM, that stands for CSS object model. We'll discuss what it is. And the third step is render 3, followed by layout and followed by paint, right? So let's dive into the first step, that is the DOM creation. So let's have a look at this documentation also. So document object model DOM construction is incremental. We'll discuss what it means. And the HTML response turns into tokens, which turns into nodes, which turns into the DOM tree. Okay, I'll explain these things. Okay, this things. So let's understand what is DOM construction is incremental. So if you have a look at the Google's search page, right, and whenever you type something and hit enter, you notice that the head section of the page, right, the part where there is Google's logo, where there is navigation links, map images, news, etc., that part is actually loaded first, and followed by that you see that the search result page are rendered. Okay, what I mean by that is the DOM can be created incrementally. Let's suppose you send one some part of the HTML in one request, and another part of the HTML in another request, right? And what browser will do is browser can incrementally add those DOM structure, and it can render it on the screen. Okay, so it's not like it has to finish all the DOM creation at one go. If you supply some more HTML to the browser in the later part of the process, then definitely that would become a part of the DOM tree. Okay, this is why the DOM trees are incremental. And what next is that token creation, right? So this is these 4 are the steps basically that is involved in the creation of the DOM, and that is characters, tokens, nodes and DOM. Okay, for example, I have taken this small code snippet for HTML. We have a HTML tag, head tag, meta, title, link, closing head tag, body, div tag with some text and closing body, and followed by script tag, and finally we close the HTML. So now when the browser starts going through these codes, what it does is it creates a token for them. Okay, so for browser, these are the characters. Okay, these are characters, and what it does is it creates a token out of them. So what tokens look like is that we start with the HTML, so it will assign a token saying it is a start tag. Okay, start tag is basically a token. Then we come to head tag, so again a token will be created, a start tag with value head. Okay, and we have a meta tag. Since meta tag is self-closing, so it is a self-closing, right? So it doesn't has a ending tag, right? So we have changed the name of the token from start tag to just tag only. Okay, it is meta. Then again we have a title, so it is closing tag, so we have a start tag title and end tag title. Okay, so whenever HTML tag ends, we give a token of end tag, and if it is a self closing, then we give it a token of tag, and if it is the opening tag, then we give it a token of start tag. Okay, this is the nomenclature. and followed by link is self closing. We have a tag, then we close the head, so we have an end tag with a head. We have a start tag of body, okay, we start tag of div, end tag div, we have end tag body, we have a start tag script, we have end tag script, and we have end tag html. So this is how the tokens are basically generally created. Now once these tokens are created, what a browser does is it converts them into nodes, something like this, okay. So it treats a node whenever there is a start tag, okay, or tag, and it creates a node. And if there is another start tag followed by a start tag, then this means that there is one node inside a node, okay. So we see that a head was inside this html, so we created a head. Again we saw a tag inside this start tag only, so this meta came here. Again we saw title, so title came here. We saw link came here. And finally when head was closed, then browser came to know that there is nothing else remaining inside this particular node. These are the only children, okay. Then it comes to body, then again it comes to body, then it creates a div and it assigns a text, okay. So this is how this DOM tree is created with the help of tokens, right? If you are there, then do pause the video, run through these tokens and try to match if you are able to form this particular tree, right? So this is the part where the DOM creation is happening, and I have explained how the tokens are created, okay. So once this tokenization is done, and we have a DOM ready, okay. So DOM basically has everything, okay, every tag. Now we come to the creation of css okay, css object model. So what is happening is when we load our css files, okay. So again this css file is again converted into a object model, okay, a tree like structure. And again the process is same: characters, tokens, nodes, and DOM, okay. So this is how the process of css is created. For css, the tokenization and the character identification is pretty different. They have their own logic, and discussing that particular logic is not necessary at all. If you are really interested, then you can search for how css particularly creates a DOM, a tokenization and other stuffs. But at this point it doesn't really matters, okay. So what matters is that let's suppose you have these tokens, okay, body and div. You give them you generate the tokens, and based upon that token set you generate this particular tree, right? Body, we have a body node, and inside a body node we have a div node, okay. But apart from these nodes, these nodes are attached with certain properties, okay. The properties are what lies within these curly braces, okay. Like the body has a font size of 32 pixels, so this property is associated with this particular node. Now when we cascade down to a particular child, all the property that the parent has is cascaded down, okay. So I have marked this font size 32 pixel as a gray area, stating that this property is cascaded down from its parent, okay. And we see that this particular div has its own property, that is color red. So I have written this color red property as well, okay. So this is why css is known as cascading style sheets, right? Because we cascade down the styles to children from their parent, right? So this is the css DOM creation, okay. So let me take you to css DOM. So the DOM contains all the content of the page, and the css DOM contains all the information on how to style the DOMs, okay. CSS is similar to the DOM but different, okay. While the DOM construction is incremental, css DOM is not, okay. CSS is render blocking. The browser blocks the page render until it receives and processes all the css. CSS is render blocking because rules can be overwritten, the content can't be rendered until css DOM is complete, okay. So what does it means? So we saw that the DOM creation was incremental, right? Like we discussed that we can pass HTML at later part of time, and they can be a part of the DOM. But this is not with CSS, okay. CSS OM is not incremental. It has to be computed once at all. Okay, it will be computed once only. The reason is that there are chances that at the later point of a stage, the CSS styles can be overwritten, and this will again trigger a repaint or layouting. Okay, I'll tell you what painting and layouting is done, but for now remember that in order to avoid layout and painting, that is why CSS OM is not incremental, and all of the construction is basically happened when it start parsing those CSS files. Okay, so CSS OM is constructed once only. Okay, so it is incremental. And again, yeah, to be noted that JavaScript has ability to alter our styles, right? So again, we can alter our styles, but that is through JavaScript. But while parsing CSS file for that particular time, we create our CSS OM at once, at one go only. Okay, that is one thing we have to note about. So CSS OM, when CSS OM is created, when we see that we come to this part, that is render tree. So when we combine DOM and CSS OM together, we generate the render tree, and that is actually what is visible on the our screens. So if you come have a look at this diagram, I'll zoom in a little bit. Okay, so if you look at this is the render tree, and in this render tree you see on the left hand side we have this particular DOM which we just discussed above, and on the right hand side we have this particular CSS OM. When we combine these two, we generate our render tree. So render tree may the things are only contained which are actually visible on the screen. So anything that doesn't contribute to to adding the pixels is not added. Okay, so whatever is present in this head, it is omitted. Whatever this HTML tag is also not contributing, so this is omitted. This script tag is also not contributing, so it is omitted. So only part that we take out of from the DOM is this body part. Okay, so we take this body part, we add it over here, and whenever we start mapping these nodes, okay, we map body with body, we map div with div, we found that these were the properties that were associated in the CSS OM. So we took those properties and applied them in this, okay, in the render tree. So this is how what render tree looks like, and this is what exactly is rendered on your screens. Okay, so up till now we have discussed DOM creation, we have discussed CSS DOM creation, we have discussed render tree, and when this render tree is done, then comes the layout and painting. Okay, I'll take you through this render tree. So render tree captures both contents of content and the style. The DOM and the CSS SOMs are combined together to form a render tree. Okay, this is as simple as that. And one thing to note that is if there is any content that is set to display none, then that particular node will be omitted from the render tree, although it will be a part of the DOM, but it is not part of the render tree. Okay, that is one catch here. Okay, now coming to layout. So layout is nothing, basically layout is like once the render tree is built, layout becomes possible. Layout is dependent upon the size of the screen. The layout step determines where and how the elements are positioned on the page, determining the width and height of each element. Okay, so layouting is kind of calculation phase for a for the CRP process. By calculation phase I mean that once you have all the nodes of the render tree present, now browser does is that it identifies that, oh, this is a body, so according to these properties of CSS DOM and according to these properties of DOM, this would be the height and width of this particular node. Now I traverse a one step down. Okay, now comes for example div node. Okay, so div may it calculates the height and width via the CSS DOM properties, and it also checks the attributes or particular via the DOM, and again it computes. Okay, so this would be the height and width of this particular div tag. Okay, and this steps is repeated until and unless we traverse our whole render tree. Okay, so this is the layouting step, and in this part it talks about this meta tag Okay, so it is saying that by default full screen browser is generally 960 pixels. One on by default full screen browsers like your phone browser, by setting meta tag name viewport content full device width. So the width will be the width of the device being used of the default viewport. Okay, so adding this particular tag is really important if you want the viewport to be the full width of the device on which you are actually seeing. If you don't do this, then by default the size would be 960 pixels. Okay, so this would this would hamper the layouting phase. Okay, so let's suppose if you are not putting this tag into your HTML, and you are setting a div to a width of 100%. So this would be the 100% would be equal to 960 pixels. Okay, but if you if suppose you are on a shorter width, for example 320 pixels. Okay, now you don't want your div tag to be 960 pixels. Instead, your viewport width should be 320 pixels. That should be of your device. Okay, so it's very crucial for you to add these properties in those. Now comes the painting part. The painting part is the simplest part. Once you have all the computations ready, how much width and height you want to assign to a particular node. Now browser does is that it just paints them on the screen via the help of pixels. Okay, so this let me read this out for you. The last step is painting the pixels to the screen. Once the render tree is created and the layout occurs, the pixels can be painted on the screen. Okay, this is very simple step. It's just that painting is like you are seeing things on your screen now. Okay, so these were all the 5 steps of critical rendering path. And yeah, and also I have a small code snippet ready for you to show you how we can actually see these steps in your in your dev tools. So I'll tell you how the setup I have done the setup up till now and what's the agenda of this particular setup. So I have created a basic express server node server right over here with me, where I am serving style.css, script.js and index.html file from this part. And my index.html is something what it looks like this. It has a style sheet, it has a script tag, it has a div tag and something else. So let me put this script tag at bottom for this particular example. And yeah, and we have a wait. I have created a wait function over here. This is just to add to add a delay on sending some files. Let's suppose someone creates a very heavy css file and it took 5 seconds to load, right? So just to mimic that experience, I have created this a wait function, and so that whenever I change this time, the load time of these files, I can show you how this css is render blocking, how this js is render blocking. Okay, so just wanted to show you those stuffs. So but before showing that stuff, let me show you the critical rendering path lifecycle methods onto your dev tools. Okay, let me hard reload this once. Okay, and what I'll do is I'll do Control Shift E to record it. Wait, let me record this up. Okay, let me record. Stop. Yeah, so if you go to the performance tab of your dev tools and go to event logs, make sure all these boxes are checked. And if you have a look at these steps, let's have a look at them one by one. So you see that we initiated a send request, okay, on the local host. I received a response. Okay, I received a HTML response, and when I received a HTML response, I received HTML response. I finished the loading of this HTML and I started parsing my HTML. Okay, so this is the parsing step. Okay, this is what DOM creation and CSS DOM creation. Okay, in this parsing, I send request to my style.css file, I send request to my script.js file, and I start evaluating my scripts. And see, here I received a response from style.css. I received the data from style. I started parsing my style sheets. Okay, I finished the loading my style sheet. I recalculated my styles. Okay, this is the layouting step I was discussing just about. Okay, the layouting was happening and I updated the layer, and see, this was the painting step. Okay, the last step was the painting. And yeah, so and this was like an event load happening. So this is the point where I got my script tag. Okay, script, I received a response of a script tag. I initiated an event load, and I started other stuffs, right? So this is, this is what the CRP life cycle method looks like. And I'll recommend you create your small dummy HTML and CSS file and see how they look, okay, in this event log. Yeah, so this was about the CRP, and let me show you how these yeah, so let me show you how CSS and JS are blocking actually your rendering, and how things actually look when they are loaded very slowly. So what I'll do is, let me for now load these style sheet for a delay of 10 seconds. Okay, so I'll add 10,000 milliseconds. Okay, I'll add 10,000 milliseconds, and I'll load it for you and see what is happening. Okay, so style sheet is still pending. I'm not able to see anything. Okay, after this style .css was loaded, again I was able to execute this JS, and after clicking OK, you can see that I'm able to see this text over here. Okay, so see this over here, see this script is over here, and we have this parsing, right? So this was let me show this again, if that was so uh, okay, browser cleared the cache. Now you see that we have this style.css over here. It is pending, we don't see any content. Once this style.css is finished loading, our script was initiated. And since this alert alert is also a blocking statement for us, so alert was again is waiting for it to be clear. Once we click OK, we are able to see this welcome to JS Cafe. Now the point is that if I move this script above, right, if I move this script above, and yeah, so and what I do is I again, so yeah, so again I have the loading time of CSS as 10,000 milliseconds. And if we try to load this again, so JavaScript is clearing the cache. Okay, now it is pending, and when this is over, then you'll see a script tag saying this is alert. Once we click OK, our HTML is unblocked. Okay, so this is how actually our scripts are blocking our rendering, and this is how parsing block looks like. And again, I think this part again will make sense to you if you have watched all the previous video which I have just covered related to loading JavaScript asynchronously, loading style sheets in asynchronously, and how things affect those stuffs. So yeah, this was all in this video. Till then, take care, see you in the next one. Goodbye.